Hello everyone. In today's lecture, we will discuss another type of loudspeaker known as the electrostatic speaker, which is also called as the condenser speaker. Unlike dynamic speakers that use a moving coil and permanent magnet, an electrostatic speaker works on the principle of electrostatic force. It consists of an extremely thin and lightweight diaphragm placed between two perforated metal plates called stators. When an audio signal is applied to the stators, an electrostatic force is generated. This force causes the diaphragm to move rapidly, producing sound waves. Since the diaphragm is extremely light, electrostatic speakers can reproduce sound with exceptional clarity and very low distortion. They are commonly used in high-end home audio systems and professional music studios where accurate sound reproduction is required. However, these speakers are expensive and require a high voltage power supply for operation. This slide illustrates a 2.1 audio system. The notation 2.1 indicates that the system contains two satellite speakers and one subwoofer. The two satellite speakers reproduce the left and right audio channels while the subwoofer produces low frequency sounds or bass. This configuration is commonly used with desktop computers, laptops, televisions, and small home entertainment systems. Compared to ordinary stereo speakers, a 2.1 audio system provides deeper bass and a more immersive listening experience. It is a popular choice because it offers good sound quality at an affordable cost. The next advancement in audio technology is the 5.1 home theater system. A 5.1 home theater system consists of 5 full-range speakers and one subwoofer. These 5 speakers includes the front left speaker, front right speaker, center speaker, left surround speaker, and right surround speaker. The additional subwoofer is responsible for reproducing powerful low frequency effects. This arrangement creates a realistic surround sound environment, making the listener feel as though they are inside the action. 5.1 systems are widely used in cinemas, home theaters, gaming systems, and multimedia applications. Now, let us understand how a 5.1 surround sound system works. The front left and the front right speakers reproduce music, sound effects, and stereo audio. The center speaker mainly reproduces dialogue, making conversations clear and easy to understand. The left and right surround speakers create environmental sounds such as rain, wind, crowd noise, and background effects. Finally, the subwoofer represents by point 1 produces deep bass sounds like explosions, thunder, and drum beats. By distributing audio signals among the multiple speakers, the listener experiences realistic three-dimensional sound. This technology greatly enhances movie watching, gaming, and music listening experiences. Okay, now let us move to display technologies. So far, we have discussed about speakers, that is loudspeakers, and previously we have seen microphones that we have started with input device and the output device loudspeaker. Now another one output device is display system. One of the earliest display technologies is the cathode ray tube, commonly known as the CRT. CRT displays were widely used in televisions, computer monitors before flat panel displays became popular. A CRT contains an electron gun that reproduces or produces a beam of electrons. This electron beam strikes the phosphor coated screen, causing it to emit visible light. By scanning the electron beam across the screen many times every second, complete images are produced. Although CRT displays provide good color reproduction, they are bulky, heavy, consume more power, and occupy more space. Color picture tube. It is an improved version of the CRT display, which we have discussed in the previous slide. Instead of producing only black and white images, it generates full color pictures using 3 electron guns. These electron guns correspond to the red, green, and blue color components. The screen is coated with tiny phosphor dots of the 3 colors. When the electron beams strike the phosphor dots with different intensities, millions of colors can be produced. This RGB color principle is still used in many modern display technologies. This figure illustrates the internal construction of the color picture tube. Notice that arrangement of the three electron guns, focusing system, and shadow mask and phosphor screen. This shadow mask ensures that each electron beam strikes its corresponding color phosphor. So means that it is striking only the corresponding color phosphor. This precise alignment is essential for producing accurate color images. Although CRT technology has now been replaced by LCD and LED displays, understanding its working principle helps us appreciate the evolution of display technology. One of the most widely used modern display technologies is liquid crystal display or LCD. Unlike CRT displays, LCDs are thin, lightweight, consume much less power. An LCD doesn't generate light by itself. Instead, it controls the amount of light passing through liquid crystal molecules. A backlight provides illumination while the liquid crystals regulate how much light reaches each pixel. This enables LCDs to display images, text, animations, and videos with good clarity. LCDs are commonly used in televisions, laptops, calculators, smartphones, and digital instruments. Next is LCD construction. Now let us understand the working principle of an LCD. Liquid crystal molecules possess properties of both liquids and solids. In the normal state, these molecules rotate the plane of polarized light. When an electric field is applied, the molecules change their orientation. As a result, the amount of light passing through the display changes. Each pixel consists of three color subpixels red, green, blue. By controlling the brightness of these subpixels, millions of colors can be generated. Because LCDs require a backlight instead of generating light directly, they consume less power than CRT displays and are much thinner and lighter. So, like this, these LCDs have many disadvantages and advantages. So that's all about LCD. In the next lecture, we'll be discussing another types of display systems are like LED. How an LED is benefitable compared with LCD, and its different types and working principle and construction of an LED. So I hope you understood the topics covered in today's lecture. Thank you.